So this is subtracting rational expressions. So is this something you want to do right now, or do you want to do 1 over 7, 1 or 7, 2?
I'm good with either.
Okay. I don't know what to do. This distraction-free stuff is just not happening. So this is, I think, 7, 4. If you're subtracting, you need to create a common denominator. Yes? And I think I showed that, like if I have a 3/4 plus a 7/12, you wouldn't add them together. You know, if you had basic math, you would say, oh, what's my LCD? And you would say, oh, okay, 12. They both fit into 12. And then you say 4 times 3 is 12. 3 times 3 is 9, right? This didn't change. And then you say 9 plus 7 is 16. And then you simplify, you see? So back to, I gotta let the dog, give me 1 second, so honestly. 10 seconds, 10 seconds. I'm gonna throw them back outside. So sorry. Life isn't always easy, is it? So if you did these, you might have said, how did I come up with the LCD? And you factored the pieces, and then you factored these pieces, and you came up, we worked this the other day, so it's on that other video. But in this case, what you do is you factor each denominator completely. So that's one thing you do. So you're going to say, okay, what is this one on the left? X, negative 48, negative 2, negative 8 times positive 6. You see? And how did I come up with it? I just play with this stuff a lot. You probably got it before me. But negative 8 times 6, negative 48, negative 8 plus 6 is negative 2. So then you put this in here. Yes, because this was a simple trinomial, and the last thing you want to do is make it difficult. Imagine, what if you decided you're going to do everything over the top or grouping? Wouldn't you make a huge mess? You know, you want to keep it simple if you can. Now this is an x plus 6. But what do you need? So you factor each denominator. So you could rewrite it with, or in my classes, sometimes I say rewrite with denominator factored or in factored form, because that helps you focus then, how do I do this? So we could just say, okay, do you all agree that I did absolutely nothing between here and there? It's identical. One is in factored form, one is in polynomial form. Then you say, okay, now I need to decide, excuse me, what is my LCD? So in this case, do you see how the LCD was the smallest number they all fit into? So do you see how this is already in here? So when you're finding an LCD, you list each factor the most you see it. And you need to look at these as separate items. So you say, okay, I have a denominator, and it's this. And you have a denominator, that's this. And you look at them completely separate. And then you say, okay, I'm going to list each one the most I saw it. I see an x plus 6 as a factor once. I see it once. I only list it once. And I see an x minus 8 once. I see it never. I list it once. Then you say, okay, my LCD is this. And what you do is here, these are steps, you know, step 1, 2, 3. This is your LCD. And now you're going to rewrite, and this is what you do in basic math. Each expression with that denominator. Now you don't have to write this stuff down. I'm just trying to clarify. And I know it's hard to keep up if you're taking a ton of notes. So I'll try to slow down, but these are harder for people. The adding and subtracting is definitely hard for students. But you rewrite each expression with that denominator. You see how this is here, and I guess I can use the spotlight, but you see how here, whoops, here we used, we rewrote this expression with that denominator because we decided in this case it was a 12. You know, I just made that up. That was an example. So what is my LCD? So you don't write a numerator, leave the numerator blank. First, leave the numerator blank and then say what happened from here to here. What happened from here to here? Nothing, right? And then you say what happened from here to here. And this is where I use a lot of different colors, especially in the classroom. I'm going to say what's missing? Oh, the x minus 8. What's missing? Whatever I do downstairs, I have to do upstairs. This is like me saying 3 times whatever I do down here to make that 12 happens, I have to do it upstairs as well, you see, because you're kind of multiplying by 1. This is basic math. Over here, it's algebra, but it's the same concept. So then you say, okay, now this, well, you could go ahead and distribute, you see? Because when you have a minus, this isn't like when you're multiplying, you know, when you're multiplying, and then you go across and then you have everything in factored form and you just cancel all over the place. You know, we talked about that last time. You cannot cancel when this is not a multiplication or division. Well, division you turn into multiplication first. But if it's a subtraction, you absolutely will not make that mistake that you make this a 5 times x minus 8 and then you start canceling stuff. That doesn't make sense because that gets you right back to the previous step. So don't do that. You have to say, oh, what do I have to do? Just like here in the basic math, you had to go across over the common denominator. Isn't that what we do? So we're going to say, oh, now they have a common denominator. Are we okay with this, how we got here? Okay. So now we have a common denominator. So then we say, okay, now we're going to write, oops, I have the mouse on. Now we're going to write everything over that LCD. And sometimes I get a little lazy, I just call it LCD. Now we're not going to write these twice. The LCD is 12, right? 12. It, you know, A over B plus C over B. Basic math is A plus C over B. Or plus or minus, doesn't matter. So then what do we do with the numerator? We go across. Well, now we have to watch that sign. Because now we need to distribute the -5 through. So then I'm going to write LCD for a minute because it's faster. So we have a 9 minus 5x plus 40. And this is, remember, -5 times x, -5x true. -5 times -8, positive 40 true. And then you combine like terms. 9 plus 40 is 49. And then the LCD was x minus 8 over x plus 6. And then we can have the argument, hey, do we need to cancel anything upstairs, downstairs? I'm like, the only time you can cancel is when you have common factors. This is not factors. Now, if I ask you to factor this, could you? So you're going to say, well, how do I factor 49 minus 5x? Do they have something in common? No, you can't do anything with it. You see it? So this is the end. Or the computer will take the denominator in distributed form, meaning back to x squared plus 6x minus 8x is x squared minus 2x minus 48. It'll take that too. Or it'll take it as a -5x plus 49 over the LCD. Are we clear? How are we doing? Helpful, not helpful, boring?
I had a question because you said you can't just, you know, take out, or you can't divide from top to bottom, basically. But I had a problem, and so like my final answer basically ended up like you know, like a 3 times n plus 10, and it was able to be, the 3 was able to be factored out from the numerator and the denominator. And when
then
I
you
put
need to
it,
cancel them.
so you can't, so yeah, because I ended up getting that one wrong, because I'm like, I thought you couldn't cancel, but you can cancel.
If it's a factor. So that's the key.
So like so whenever I did it, it was like I said, it was 3, and then in parentheses I had n plus 10.
If I went ahead, will anybody hate me? Are we still taking notes? Or are we okay?
Okay.
We're okay. I just don't want to clear this. We're okay. Okay. So if you have something, so if you had, let's say you had a 3n minus a 39 over, you know.
It was like 15n.
I don't know.
If you want, I could give you the problem.
Oops. Hang on. We can if we want to wait, or I was just making an example and they don't always turn out well. So let's say you had something like this, you know, like once you put stuff together and then you're going to say, oh, I'm going to factor this. So the numerator, you pull the 3, the denominator, they both have a 3, and then you have a 5n plus 4, for example. Do you see how this is now multiplication? And if you cancel this, you're really just, this is just really a 1 times. You see what I mean? 3 divided by 3 is the 1. So this does cancel.
Yes. But if you had it in the factor form up top, that would not be or that wouldn't be able to cancel out, correct?
So if I had, hang on a minute, 7n minus 12 over 15n plus 12, you cannot, or even a minus, whoops. Let's make that a 12 and let's just call this a plus. It doesn't matter. You know, if you had this, you cannot cancel these. That's illegal. Illegal.
Okay. So then that,
because it's plus.
So then that would mean on your left example where you were able to cancel out, if you were to write the answer like the top one, is that still not considered correct? If that makes sense.
Meaning like
if you wrote it, yes, if you wrote it like that in the answer box, is that not considered correct?
No, because it's not simplified.
Okay.
You see, you always simplify at the end. So this is like in 7-1, you wouldn't put this in a final answer because 7-1, the whole idea was factor, factor, cancel, cancel. So you have a, you know, if you have a numerator, denominator, you always want to factor in. That's like you saying, hey, I want to put 12/16 or, well, yeah, as a final answer. Will the computer take it? You know, if you go back to the basics and pre-algebra, would you have been able to put this into a final answer, or would it have said that's not going to work because you can simplify it into a 3/4, you see? So
I don't know. I'm having a hard time distinguishing between the left top answer and the right top answer.
Okay. So
no, it's because it's not factored.
Yes.
And you can't pull a common denominator or a
so you can't factor this, you know. So since this is not factorable, there's nothing you can cancel between upstairs and downstairs because this is pluses.
Okay, that makes sense.
Yes. So if you have multiplication, this is the whole idea that you have factors. And when you have a common factor upstairs and downstairs, you can cancel them.
Okay, that makes sense.
But you always have a lot of good questions and other people are shy and they don't want to ask them. So I'm always glad you ask. And I'm still taking roll and making sure I got everybody. I think I have all of you down. Oh, Kelsey. I don't know. I think this is it though, right? We have 2, 4, 6, 8, 10 total. Okay, so 9 attendees, better than usual, but still out of 48 people or something. It's not a great turnout, but I don't know if they read their announcements. I don't want to hear it. I mean, I said this before. I don't want to hear it at the end. Oh, I go past this class. I'm like, were you here? Did you try? Did you email me? You know, it's just, yeah. Okay, so what do you want? You're paying for this. This is multiplication. Do I do it or skip it because we worked some last time? And those of you who were here last time, you know, and again, if you ever have problems, what do? You email me and I'll work it for you, whether I work it as a video or I work it with the little screenshots like I do send Markeisha some, and she says they're helpful. So, and if they're not, I'll always be glad to make you a video. And I'm also happy to meet you on Zoom. Doesn't matter. Do you want to work this? This is multiplication. So you go across the top and across the bottom and you factor, factor, cancel, cancel. Factor like crazy, factor the heck out of it is what I say, class. And then you cancel upstairs, downstairs. Do I want to work it? Or there's one with division. There's some cues in here. It makes life interesting. Yay, nay? You have to communicate because I'm here to work for you. All I see is a few facial expressions. Now, if you're chatting, I can't see the chat. So one of you needs to hang on here.
I would be good with working some of those word questions, like the 6 times the reciprocal one.
Yep. Okay, so focus on those word problems. Okay, so here you understand that you keep, change, flip, and then you factor, factor, cancel, cancel. So if you want help with any of these, I'm saving this. You know, it says chapter 7 quiz examples. So this is directly, some of this is directly off your quiz. And then after a while, I just started grabbing some additional, like I saw one of these on the quiz and then I started grabbing additional, there might be 2. I started grabbing additional ones that I found in that homework section because this is what takes time. These are the distances, rate times time. There's a table I make that really makes life easy. The computer makes a similar table. My table is slightly different. So 2 trains leave a station, make me run away, right? Driver a car, pilot can fly. And then we have complex fractions. Those are 7, 7. They're not bad. Please don't get scared of these. If you can do the magic trick, these are cake. So I'm happy to work them too. Okay, so hang on a minute. So let's start with one word problem. And there were word problems in chapter 6 that get you warmed up. And then there's word problems in chapter 7 that get a little more interesting. Now I have you find the number, okay. Oh, Lord. Sometimes I never complain, these dogs are wonderful, but the one time you need them to be quiet. Yeah. 6 times the reciprocal of a number. Oh my gosh, I'm overwhelmed. Let X be. Yes, this is how you do it, honestly. You don't run because you don't have a choice. You can't run from these problems. You have to embrace them. So you let X be. So then you say, what am I looking for? Oh, at the end it says find the number. So a number. Yes? Let X be a number. Okay. And then, yes, before on some of the word problems, I said let X be the last word, the first sentence. That's not going to work on these. That's like if you have a, back when, whoops, I'm trying to make sure stuff makes sense, but back when you had a rectangle and it said you have a base and a height and it's 3 longer than twice the height, then if the height is X, then this is 3 longer than twice the height. You need to do it that way. But this is not the same. So this is 6 times the reciprocal of a number equals 3 times the reciprocal of 3. You should have done something similar in pre-algebra. So you say let X be a number and then you just translate 6 times. 6 times, how do you write that? 6 times, yes? And then what's the reciprocal of a number? If X is a number, then if I ask you, okay, if I tell you 4 7s and I say, is this a number? Yes. What's the reciprocal? So this is the number and this is the reciprocal. What's the reciprocal of 4 7s? Reciprocal means flip it. Yes. So the reciprocal of 4 7s is 7 4s. Okay, we have no problem with this. But when we say let the number be X, then people freak out over the reciprocal. I'm like, okay, X can be expressed as a fraction? Yes. X over 1. Then what's the reciprocal? 1 over x. You see? So you let x be a number. 6 times the reciprocal of a number. Reciprocal of a number. Yes? It's just translating. So this is the 6 times. The reciprocal of a number is this piece. See? That's just English in the math. Equals maybe should be an equal sign. And then, do you see how this is also puts it in the order that you need? And then 3 times the reciprocal of 3, that's kind of a silly, isn't it? That's silly. If the number is 3, then the reciprocal of 3 is a third, and 3 times a third, isn't that just 1? Isn't that kind of silly? I can't help it. This is computer generated. Excuse me. Okay, 6 times 1. Now you're multiplying fractions, so you get 6 over x, true? And 3 times a third is just 1. So if you have trouble with this, use a calculator, honestly. And then you have to solve for x. So here you can do what? You could, if it's an equation, you can cross multiply. You could use the magic trick. And it's all the same thing. So let me show you. A over B equals C over D. You know, this is a rule. If A over B equals C over D, then AD equals BC. This is cross multiplication. But all it means is when you have an equal sign and you have a fraction equals a fraction, but this only works if you have a fraction equals a fraction. You know, so you could write this 6 over x is 1 over 1. And then you say, okay, that means 6 times 1, right? Go across, cross multiply is 1 times x. So x is 6, you see? That's using cross multiplication. If you like the magic trick, the reason I push the magic trick is because the magic trick works even if you have more than one term on each side. This only works when it's exactly like this. But if you had something like x halves plus 3x over 5 equals blah, blah, that means the magic trick will work for all of them. Anyway, I'm going to work at the magic trick. You have options. That's the further you get into math, the more options you have. Okay, so using the magic trick, you say, what is my LCD? In this case, you see, it's really simple. But in this case, it's an x, and you multiply each term by the LCD, and all your fractions disappear. So what you do is you put an x in each numerator. And it seems a little silly on this really basic one, but you need this magic trick on those crazy complex fractions. So there's a reason I push certain things. This is not, this basic stuff down here is not going to help you when things get a little weird. So this is the numerator and this is the numerator. So you get the same result. The x's upstairs and downstairs, you see how they cancel? So then you get 6 equals 1 times x or x. Either way, it doesn't matter to me right now which way you do it. Now, this is a word problem. It's funny because then I get distracted and I'm like, oh, I circled that. That's bad, because usually in the classroom I say it's a word problem. It needs to end in words. You know, it starts in words and needs to end in words. So the words that ended really truly is here. If you set this up the way I'm asking you to, so let x be equals 6. This right here is technically in words. X is a number equals 6. You see? So, but we're not in the classroom, so it really doesn't matter right now. That's me being a little bit picky. How to cake? Less intimidating now that you've seen one? And then when you get comfortable, we switch gears. But we're not going to solve this one. We're going to just translate. Okay, find the number here. I'm going to move it over. Okay, so let's try this again. You know, like in the classroom, we'll take our time and actually do it, but let's just set this up because the setup is the problem. Creating the correct equation. Lots of people want to immediately go into equation. I say, do not do that. I see a lot of words, I'm overwhelmed, let X be. Yes? And then you're going to say it's a number. And this will help you translate. Now you look at the wording. If 3 times a number, and this is, commas are very important. You ever hear that one, comma saves lives? Like, don't eat grandma, let's eat grandma, or let's eat grandma without a comma. Anyway, comma save lives. If 3 times a number, 3 times a number, comma, added to 4. You see, you take 3 times a number, added to 4. And why is this important? It really isn't, because 3x plus 4 equals 4 plus 3x, you see. But if it said subtracted from 4, then it does matter. So I'm going to always follow the wording. Is divided. Is divided by the number plus 2. See, this is hard. If 3 times a number added to 4, this whole thing is divided. This is not the one time where is does not mean an equal sign. This piece is divided by the number plus 2. The number plus 2. You see it, how I translated that? Like, now I'll have to solve it because I want to make sure it's clean. If 3 times a number added to 4 is divided by the number plus 2. Do you see how, does it read okay? The result is 8/3. And now you have to solve it. Now you can cross multiply because you can multiply the 8 times the x plus 2, but you have to then distribute. See it? And you can multiply the 3 times that 4 plus 3x or 3x plus 4. Or you can do the magic trick. So let me throw that magic trick up there. LCD. I see a 3. I see an x plus 2. You see how x plus 2 doesn't factor? So my LCD is not 3x plus 2. Please don't do that. My LCD is, I list the factors, the most I saw them. I see a 3 and I see an x plus 2. And now this is my LCD. Yes? This piece. So what I do is I put parentheses and I put it in each numerator. So times 3 times x plus 2 times 3 times x plus 2. And I don't do anything to the bottom. Do you understand that when we're making an equation, we're not creating the same denominator, we are getting rid of all the fractions. That's why this is called the magic trick. Now in this specific problem, I'm telling you, yes, cross multiplication is fine, and they're going to push that in the book. Okay, but I want to show you something though. You're going to see this here in just a second, that it's all the same. So what's left? Do you see how upstairs, downstairs, now this and this cancels because this is multiplication. So on the left side, you're going to get a 3 times 4 plus 3x or 3x plus 4, doesn't matter. On the right side, these two cancel. You see? Upstairs, downstairs. You have factors, common factors. And then this is left over. And now you have something that is manageable. Manageable. My English, terrible. Okay. And then you FOIL, distribute 12 plus 9x. Now I got to solve it. I got to see what the answer is. If it's some weird fraction, you make a mistake. Okay. So let's subtract 8x. So we're going to get 12 plus x equals 16 minus 12 minus 12. X is 4. And then we're going to check it in original wording. I don't always have time, but I want to know this now. And I'll show you this actually doesn't take very long. I'm gonna do it up here in like, I don't know, brown. It won't let me. If 3 times a number, what is 3 times 4? 12. Added to 4 is divided by the number plus 2. The number is 4, so 4 plus 2 is 6. Does that equal 8/3? Question mark. So 16/6 equals 8/3. You see, it's really easy to check it. Divide by 2, divide by 2. Anyway, so we're going to do some distance rate times time problems, and there you will learn this is a proportion, so we can use that there. I just really like the magic trick because it'll work on those crazy 7/7 things. But in this case, what did you have? You had this thing. This was your original, yes? I mean, your original translation. Now let's look at it real quick. If you just cross multiplied, you're gonna get 3 times 4 plus 3x and equals 8 times x plus 2. Do you see that this is identical? So it doesn't matter which way you do it. Yes, all the same. That helped make it worse, I don't know. It's really hard to gauge by your expressions on Zoom. How are we doing? Worse? Are we good? Can we do like a thumbs up or thumbs down, or this sucks or what?
It makes sense.
Okay, good. I miss the classroom so much. It's a little bit depressing, I'm telling you. I'm just being honest. You know, this whole living through a pandemic, you know the feeling. Everybody knows the feeling because we're all feeling the same thing. You know, it's just really hard sometimes because as much as I love to hang out on my farm, I need some people. Which one do I want to do first?
That top one, the supposed 2 trains.
Oh man, but this one I might have to work it a little differently. Okay, so what I usually do is I'm going to draw a little picture, okay? So I have a picture, and this is my train station. Hauptbahnhof, Deutschland. Okay, so 2 trains leave a station, and they go in opposite direction. So let's say this one is some train and this one is some train, but let's say they travel the same amount of time and one goes shorter, meaning, do you understand visually that this thing has to be the slower train? You see it? Slower. So here it says train B travels 10 miles per hour faster than train A. So I'm trying to debate on, do I want to play with this here a lot, or do I want to go ahead and make my table? But math is supposed to be about critical thinking and you working things out. And when you can actually work it out. So train B travels 10 miles per hour faster. Do you agree that train B travels further in the same amount of time? So this must be train B. You know, and in the classroom, I'll draw a train, but we have limited time. Okay. And then do you see how when it says the trains are 414 miles apart, do you see how the distance between them is 414? You see? Now I like a visual like this, but I'm going to push the table. Sometimes you need both. Okay. So let's make the table. I'm telling you, this table always works. Let me undo, give myself a little space. This table is great. Just do it the same. In the book, they're gonna say, so you're gonna row a boat down the river, and then you're gonna row a boat upstream. Do you agree with me that the road, if you're going upstream, you're fighting against the current? You know, even if you're like a little liquored up, I've never gone on a float trip. I just hear the stories. But anyway, so if you have a lot of liquor, you probably want to go downstream because the current helps push you, you know. But what I tell people is always in the table, don't worry about it. Just always make it a standard thing. You're going to put faster top and slower in the bottom. Instead of me worrying about what's train A, what's train B. Just do the faster in the top, slower in the bottom, it always works. And then you're gonna say, okay, do you all agree distance is rate times time? So the
Yes.
distance I travel is how fast I travel, how many hours. So if I'm going 60 miles per hour for 2 hours, I'm probably traveling 120 miles, you know? I mean, a lot of this is common sense, and a lot of students struggle with it. I'm like, you need to get in your car and think while you're traveling. Okay, so I usually like to put the rate first. And then the time. And then the distance. Whoops. So rate times time equals distance. Yes? So then we go to the problem and start looking, you know, and some people always like to do the rates with an R. I'm going to say let X be, and I know I'm all over the place, but I haven't done this in a few months, so I just have to think it through again. But you want to say let X be. In this case, you have to. Train B travels 10 miles per hour faster than train A. Or slower. Yeah, I mean, train B travels faster than train A. Let X be the slower train. Or speed of the slower do you see what I'm saying? It's a speed. Speed of slower train, because this train B, the train B is based on the slower one. So train A or train A, it doesn't matter in this case. But I always like to say faster and slower. So do you see how here in your rate item, you would say the slower one is X, you see? So here, instead of saying A and B, you should think to yourself and say that's the slower. And you should say that's the faster. And then you say, oh, the faster goes 10 miles per hour faster than the slower. The slower, let X be the slower. And then what goes here?
X plus 10.
You see it? Because it's 10 faster than the slower. Now, sometimes there's more here, like on the ones where you're traveling with the current and against the current, you're going to have an X plus 10 and an X minus 10, but people try that here, it's not going to work. Here, you really just have to say, hey, my slower train is X, and then you base it off of that and you make this work. Now, what's your time? 4.5 hours, so just call it 4.5. You see? Oh my goodness, what is up with these dogs? And they have to do it right in front of the door, like I don't have a huge backyard. Now here people want to put 414, and I'm going to tell you that is not true. Do not put 414 in here, because if you put 414 in here, you're telling me that the faster went 414 miles and the slower went 414 miles in the same amount of time. It doesn't even make sense. If you go faster, you're going to not travel the same amount of time. But what you do is distance is always rate times time. Do you see how you have your rate and your time? Can't you just say distance is rate times time? Does that also mean distance is times rate? Do you see what I'm saying? Because of commutative property. Could you then not say distance is 4.5 times that X plus 10? I don't know how far that fast train traveled. I don't. Do you see what I'm saying here? That's why I love this picture. You need this picture, because I don't see how fast this one traveled, how far. I just know that the two of them together in 4.5 hours traveled that far, because that's how far apart they are. So then this is why we need a table, and we set it up like this. The slower is 4.5x. And then you take and say, oh, and you can translate this, the distance of the faster plus the distance of the slower equals?
414.
Exactly. You see it? And that's why I like that picture. Sometimes they say they go in the same direction, you know, so this is the 414. You see? Distance of faster plus distance of slower is 414. And I do like to show this though. If they went, what if they went in the same direction, you know? So here's your train station, Bahnhof, and then one goes here and one goes there. You see it? And this is the faster, of course, and this is the slower. Do you then see that the distance, when they say they're 300 miles apart or something, do you see how the distance between them would be the distance of the faster minus the distance of the slower? You see it visually. So this way you have to use some common sense. You can't just always memorize. I mean, you have to memorize some things and then you have to use your common sense. But this makes sense in Brown, right? So then you just fill in, oh, what's the distance of the faster? 4.5 times 4.5 times x plus 10. Today is not easy. This lesson is not for everyone. But if you are here, your life will be a little easier than if you're not. And then you just distribute. And this is the one time where I use some calculators sometimes. I'm still going to try to suffer through it without. We can do this without a calculator, folks. Trust me. And I'm not the greatest at the math in my head kind of thing. But 4.5 apples plus 4.5 apples makes 9 apples. Do you agree with me?
Yes.
And then 414 minus 45. No, I'm not the greatest at doing it in my head, but I can do anything writing it down. But I'll do this German style. 5 to 14 is 9. 5 to 11 is 6. 369, use a calculator. And then go ahead and let me suffer. You guys have a calculator. And then I'm going to do this a long way. 41.
41?
Yeah. Even without a calculator, you know, 9 goes into 36, 4 times 9 is 36. Then you have that, and you have just a 9. See what I'm saying? You don't need a calculator. But so x is 41. Then you go back and say, does that make sense? So if you get here and it says 41 million, 41,000. I mean, oh my gosh, how many times have I had students tell me that the current of the river is 4,520 miles per hour? That doesn't exist. You're going to time travel if that's the case. Anyway, okay, X, does it make sense? 41 miles per hour. Wait, train. The trains are 440 miles per hour. Find the speed of each train. So if you said the faster is, the slower is X, your final answer here, I'm going to do it in a different color, do it in black, is 41 mile per hour. Or this, and trains can go pretty slow. Or here, train A is 41 miles per hour. And then X plus 10 is the faster. So it is 51 miles per hour. Is it reasonable? Well, yeah. A slow passenger train, maybe. So, how are we doing? Horrible?
No, is that the final answer? Yeah, the speed of each train? Okay.
Yeah, right? So you have this one and this one.
Yes.
Now let's do another one. Now they shift a little, but this little table here always works. And then sometimes it turns into something like this, and sometimes it turns into a proportion. So let's go to another one. Now we're going to fly an airplane. And I didn't look at the order of these. I just grabbed a bunch because this is hard for people. And again, I have that word problem video. It's already in there. And it's a lot more professional than this. Okay. A plane flies with the wind, against the wind, with the wind, against the wind. You see? So these two are pretty much identical. Find the speed, or if the pilot speed still is 3, fine. Okay, so these two are really good. Can you see, because I'm moving them, can you still see all the writing? Okay, so I need to give us some space. What normally happens is, oh my gosh, I see the words, I want to run away. No, I have to tackle it, let X be, right? And then I'm also going to say, if it's a problem like this, always do the table. Table always works. I'm trying not to make it super big because I still have to write. Okay, and what do we do with the table? You always say faster, and then you always say slower. Well, I hate to say always, because then there's always that case, you know? And then we're gonna say distance is rate time time, so rate times time is distance. That's what I like to do here. And so this is how you do your table, every time. Okay, now, I gotta go back and read. A pilot can travel 450 miles with the wind in the same amount of time as 396 miles against the wind. Find the speed of the wind. So what are we looking for? The speed of the wind. You see it? Wind speed is probably what I should say. Why does she have to yap right in front of my door? Wind speed. And my husband could have locked them in there. He's in the playhouse out there. They have air conditioning. I'm like, why can't he put her in there? But no. Because you see, the unknown is wind speed, yes? Now, I'm flying an airplane. I'm going with the wind. Do you believe that it's faster? The wind helps me, yes? So it's what my plane can do, and the wind pushes me forward, just like driving the car or whatever. So do you agree the faster is going to be what he can do in still air? This means what can the plane do if there's no wind? You know, this is if no wind at all. If there were no wind at all, then it would fly 329 miles per hour. So faster, hey, I'm going to go 329 miles per hour plus the wind speed because the wind is pushing me forward. And the same exact concept is if you're rowing a boat, you know, the boat, the current is pushing you or helping you. Slower. I can fly the airplane at 329 miles per hour. I'm fighting against the wind. And this is where you have to be careful. 329 minus x, or x minus 329 does not equal. Some people always put the x first. You cannot always put the x first. What you need to do is always, you might want to put a note down for this. This will really help you. Always put the current or the wind speed. I don't want to do yeah, if I do that, or wind speed. Last. Meaning, what I mean by that is whichever one of those is the wind is what you do last. Right here, that yellow. So you're going to say, oh, what can my plane do? And the current helps, or the wind helps. What can my plane do? The wind fights me. Otherwise, you're going to have problems. It won't work. Do we know the time? So you go back in the problems. Do we know the time? No clue?
No.
We don't know the time. It's not even asking us, hey, how many hours did it take or whatever. Nobody's saying anything like that. So you have to be very careful how you fill the table in. But what do I know? I'm traveling 450 miles with the wind. So 450 goes here. And don't put M's or anything in there like your miles and stuff. Do you see how I can do 396 miles against the wind? So 396 goes here. Do we all agree the slower airplanes flies 396, the faster airplane? Because people switch these around. I'm like, you gotta make some sense. That this makes sense to me. Can you feel my pain? Where's my gun? Hang on. Hey, get in here. I'm just kidding. I have a terrible sense of humor. Okay, time. I don't know, but what I do know, you see how you're given all this stuff? It looks a little different than earlier, but distance is rate times time. If you were given the distance and the rate, could you tell me the time? Time is distance divided by rate. You see, because you would divide by R and divide by R. Does that help? Make sense?
Yes.
So then here you just say, oh, my time is the distance divided by the rate. And that time is the distance divided by the rate. See? Because you're giving yourself that if you fill the table in the way you should. Whoops, that's a 396 because it's that distance that was given. How are we doing? Filling this thing in is the most important thing you'll do, and I know that's why I take forever on it. And then this is key. Here's a key word. In the same amount of time. So now I can write an equation with this. Can you see it, where I'm going or where we're at? You're like, yes, 5 minutes ago. Get it together already, lady. The time of the faster equals the time of the slower. And if you'd set, I mean, everyone is a little different, but if you set your table up right, everyone is going to be cake after that. And then we cross multiply, you see, because you have this is a proportion. So you cross multiply like this. So you say 450, because the rule again, and I don't want to always assume it, because some people do this and then they still have a fraction. But if A over B equals C over D, then AD equals BC. Do you see how this is a rule? So what you don't want, you see how here they have no more fractions. So if you still have fractions here, you're doing it wrong. Okay, so this times that equals this times that. And this is the one time I do actually need for you to use a calculator. This is going to be big numbers, or, well, what are we trying to find? Find the speed of the wind. It better not be too crazy. So let me use my calculator though, if I can see. It's dark.
Oh, that's already crazy.
The numbers are big. This is the only time we have big numbers. Hang on, let me turn on a light or something. Whoa, that's bad. It doesn't necessarily help. Hang on, if I turn this on, it gets too bright. Isn't it? 450 times 329. Just check me. 148,050. Whoops, where are we at? Minus 450x, right? Because I distribute it. Yes, these numbers are ugly, but the final result should not be ugly. 396 times 329. Yes, and we could do all this by hand too. If you had pre-algebra in the classroom, you know all about it. And it's fun, but not right now. We have other things, bigger problems. And then you just isolate or bring the, do you see how if I move some of you get hung up on this and you want your x's on the left all the time. How about this time we add 450x? Oh my goodness. What are they hearing? 846. So I'm going to do two-step at once. Whoops. 846X. And then 148,050. So some of this is basic. You should be able to handle it. Ay, ay, ay. Between that and a 3-year-old, I have to laugh a lot or cry a lot. Okay, and then you get X equals that number divided by 846. Let's hope it's clean. 21. And then we ask, does that make sense? Reasonable? Now, first of all, it's not some weird fraction or decimal. Wind speed is 21 miles per hour, reasonable wind speed, right? Yes. So find the speed of the wind. Now, they could also ask you, hey, how fast was the faster one going and how fast was the slower one going? You see how they never asked you, but you could tell them this. This is all they want right now. Because we said here the wind speed, you know, and that goes together with that answer. But if they asked us how fast were they going, you just add the 21 here and take it away from here. And that still makes sense. Hold on. Now let's do the next one, but a lot faster. Clear? Are we, can I clear? Yes, please. Delete. Let's set up another one, but we're not going to solve it. I know you all have kids too and lives. Okay, a plane flies 465 miles with the wind and 315 against the wind in the same length of time. The speed of a wind is 25 miles per hour. Find the speed in still air. Okay, so we're asking, so this is the thing, you can't always let X be the same thing. We're going to say let X be. In this case, I need the speed of plane in still air. So I'm not looking for the wind speed. I'm looking for how fast can that airplane fly if there's no wind at all. And then I do my table. And then I'm going to say faster and slower. And then I'm going to say rate times time is distance. The plane flies 460 miles with the wind. So we've done this before. You see how that's easier and faster as you do it a couple. And then 315 miles against the wind. And then I want to sing that song. But that's from the 80s or something, before your time. And if the speed of the wind is 25 miles per hour, you see how I said, don't let X be the wind speed. Let X be the wind speed if you're looking for the wind speed. But I'm given the wind speed, you see? So, wind speed is given, is 25 miles per hour. Okay, so that's given. So always put the current last or the wind speed last. So here we're gonna say, hey, how fast can I go? I can go as fast as my plane will take me, plus the wind is helping me. I'm gonna go as fast as the wind will, or my plane will take me, and then I'm gonna fight against the wind. So this time the X leads. So it's not always X first or the X last, it's the current or the wind speed is always last. How are we doing with that? Like the old stuff. And then the time, yeah, and the time is distance divided by rate. So if you're doing these that way, you're not gonna struggle. If you get lucky, some of them might be identical because I grabbed them off your homework. And then you say, oh, I have a proportion, time equals time true, right? So you say 465 over X plus 25 is the same thing as 315 over X minus 25, and then you solve via proportion. And I showed that twice already, so I'm not going to go there now. Yes, should be something reasonable. So mainly I want to help you set up. I didn't know if there was one where you're rowing a boat. I was kind of hoping there was a boat. Are we good? I don't know if you're taking notes. No, okay. We're good. You can always take a screenshot, or I am recording this. I don't know if anybody wants to watch this. I need to go in there and see if anybody watched this. Here's a pilot. I don't see a single boat. Usually I like to row a boat. You see how we did one very similar? You can handle this, no problem. These take a little practice. Hang on. No more word problems? Nope. Okay, so. Oh, I don't know if I want to deal with the driver and the car trip. I think we did them all. Yep. Okay, sorry. Don't let it make you dizzy. It's right there. He drives at 2 different speeds. He drove 90 miles at a lower speed and 300 miles at a speed of 50 miles per hour faster. There's twice that's been driving the slower speed to find this 2 speeds. So actually, I'm not going to do it either, but I'm going to set it up. Let X be. And then we're going to do our thing. Whoa. Fast. Slower. Now this is the same driver. Let's see what happens here. I never really know what's going to happen. That's what keeps this interesting, actually. Yeah. You have to be careful. He drove 90 miles at a slower speed and 300 miles at a speed 50 miles per hour faster. So do you agree that let X be the slower speed? And that makes this the slower as X. You see the rate. And then he drove 90 miles at a slower speed. So you could go ahead and put that 90 with the slower. You see the 90 miles distance. That's the distance you're covering. So I might not be exactly where you are mentally right now, but I have to sort this out so I don't get confused. And I go 300 miles. That's the further distance at 50 miles per hour faster. And the key word is faster, meaning this is X plus 50. Do you see it? 50 miles per hour faster. And this is all critical stuff here. And then do you have time equals time? Not necessarily. This is where you have to be careful. Took a day trip. He spent, the time spent driving at the faster speed was twice that spent driving at the slower speed. So I don't want to call that 2T. Nope, 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 nope. We're not going to do that. We're going to say 2 times, what is my time? Distance is rate times time. Time is distance divided by rate. And then the slower is just the distance divided by the rate. So this one's a little more convoluted. But you know that in 2 times that time is the same thing as 1 times that time. And that should work okay. So you're going to distribute this first as 2 over 1, so you get 600 over X plus 50. And I hope this is all right, because now you have to cross multiply. So let's hope, huh? Does this come up with something reasonable? Where's my 300? Oh, 2 times 300 is 600, okay. $4,500. Help. I can't fit it. I have to scoot you over. Distribute. Catch me if I'm wrong, because you guys have how many brains? Lots. I only have one. I don't know. I'm really nervous now. I did this wrong. Whoops. Already 8:20. $8.82. I'm a little worried about that. Who drives 8.82 miles per hour? Right?
Yeah, no, that doesn't make any sense.
No, it doesn't. My table's good. And now I have to dig into this. I'm gonna have to take a screenshot and fix it. Unless somebody can help me real quick and fix it. I mean, I'm a human being. I make mistakes like everybody else, and I'm on in front of everybody. But at the same time, there's no excuse. Twice that spent during driving at the slower speed. Find the 2 speeds during the trip.
Oh, because we didn't find the. They're going at different speeds, right? So it shouldn't be.
Is it possible that the faster, we can check our work, but usually this is a clean number. Usually if it ends here though, it'll say, and I did not dig into you'll see this in my math lab, it'll say round to the nearest mile. You know what I'm saying? Mm-hmm. So what if, now this is the slower one. What if we rounded this to a 9? You know, let's just see if this will check in the end, if it'll make sense. So then we would have the faster would go x plus 50, so 59. That is a reasonable speed, isn't it?
Yes.
And then the slower is super slow. I mean, sometimes these computer generated things make me think I'm wrong too. But if I drive day trip, I'm taking a day trip, maybe I'm going super slow, I don't know. He drove 90 miles at a slower speed. So if I went 90 miles times 9 miles per hour, or times miles per hour, you see how these then stuff cancels. Hang on a minute. But I'm gonna not worry about these little things. I'm gonna say 90 miles at 9 miles per hour plus 300 miles at 50 miles per hour faster. If the time spent driving at the faster speed was twice that spent driving at the slower speed. So would that make sense? It's past my bedtime. I'm not trying to make your life worse. I was supposed to just make it easier, but setting it up is right. I don't know what happened here. So I have 810. Now I'm all hung up on this. Plus 300 times 59. Gosh, I'll have to cut this one off because I don't want to make it worse when I'm sharing this stuff. Sorry, folks. That doesn't make sense. I'll have to investigate. Just keep the table for now. Let me take a picture of this whole thing. Sorry, folks. I'm not perfect, never said I was.
It happens. This is where my brain goes in math. So
Well, it's late, but that's no excuse, you know. It's no excuse, but I am kind of fried. I'm not gonna make excuses, but if you checked your grades, I did a lot of grading I got up with my husband at 4.
yes.
That does not help me stay sharp till late at night. But again, no excuses, but I am a human. Sometimes it helps students. We know we had no problem with these other ones. It's that twice thing that messed me up. Are we fried, or can we do the complex fractions?
If you could work one of those, that would be great. I haven't even made it this far, but I'm pretty sure I'll need some.
Okay, or I'll do it later this week, but if somebody wants to show up. There's 2 of them. So I'm gonna do them. They won't take long. They're not like word problems, folks. Don't worry. Okay. You're gonna use, if it's a complex fraction, whoops. Complex fraction, don't make that scare you. You're gonna use the magic trick. If you don't understand the magic trick, you need to learn it, and you need to learn it fast. So what you're gonna do is you're gonna have you're gonna multiply each, you look at these as 4 individual pieces, okay? This is called a main fraction bar. It's a big old fraction bar. And then you have fractions upstairs. So you want to think about what is my numerator and what's my denominator, okay? And magic trick, just put it on there. Put LCD in each, wow, I'm a mess. Each numerator. So the LCD, what's the LCD? You have an X. You see how you look at all your denominators? X squared. So what are you going to put in your LCD? Is it X or X squared? Smallest number they both fit into.
X squared.
Right? X squared, because you would list them as individual factors. You say, I see it once, I see it twice. I listed the most I saw it was twice. Calvin, I'm in a meeting, honey. I'm almost done. And then you put it in each numerator. You see, just put it in each numerator. And then you're going to keep that main fraction bar, okay? So these look intimidating, but they're not terrible if you can, and then you just simplify this piece. What is X squared over X? You see? This is stuff you've done already. And you cancel that X and X, you see? And isn't it just an X left over? So this ugly thing turns into an X plus 4 times X squared is 4X squared. Come here, sit down for a minute.
Can I tell you something?
Well, nothing private because we're on Zoom. Okay, so what is X squared over X squared? You see, X squared over X squared is just a 1. So that's just a 1. I'm almost done, honey. Minus 16 times X squared is just 16X squared. You see it?
Mm-hmm.
Now, I don't find this ideal. Usually what I like for something to factor out. And did I make a mistake? No, I put an X squared in each numerator, yeah. So then if this is the original, this is the end. I don't like it. Usually you will then factor, cancel. Hi, look, the little girl is
Hi.
smiling at you.
Can I watch one mission from Lüneburger?
Oh, that's German, a show. He wants to watch a German show. 9. Okay, so if sometimes you're left with an X plus 4X squared and an X, I don't know, you know, I'm just making this up now. Then you could factor the numerator. You see? If, you know, and then you would cancel those, but only if you have multiplication. You see? But here, you can't cancel that 4 and that 16, that's illegal. You cannot cancel those x squareds, that's illegal. If you can factor it and cancel. Even if you take that x out, you're not going to do anything because the denominator is not factorable. Is that clear?
Yes.
And we're going to scroll down. And I'm just going to show you what the LCD is on the next one. Now that I messed that word problem up, I'll have to figure that out in the middle of the night. That's a brain teaser. Okay, so some complex fraction again. And you're going to figure out what's my LCD. And you look at each denominator. You factor each denominator. And then you list each factor the most they appear. X is just x, x minus 1 you cannot factor, so this is it. So your LCD is actually x times x minus 1. That's your LCD. That's not your final answer, but that's your LCD. And then you put that in each numerator. So leave yourself a little space, but this makes life, and then it'll be really easy. And I know you guys are, you know, it's been a long, I understand everybody's tired. It's just, we have to figure out if we're going to get together again this week or if this is it. So you put parentheses, and then you just put that LCD in each numerator. And then we'll see what happens in the next step. This is why you use colors. Colors will help you. And then I'm going to simplify it some, and then I'm going to leave you hanging with it because you know how to do the rest. But do you see how what cancels? I'll do that in bright green if you can see it, or maybe it, yeah, can you see it bright green? I don't know. The X here and that X here, you see how they cancel? What's left? Mm-hmm. This binomial and this binomial, so you're going to have to go ahead and put this here. And then what cancels here? This one and this one. And then what cancels here? The X and the X. And then you have a plus. And what cancels here? This X minus 1 and this X minus 1. And now you have to, you can't just cancel stuff. Now this is where you have to watch that again. Can you cancel that X and that X? No. Can you cancel that X minus 1 and that X minus 1? No, because of this piece here. Yes? So you have to FOIL and combine, then factor and cancel. So, yes? I'm so sorry, it took forever, and some of it is the word problems, but they take a long time, but that last one, it got me. I'll figure it out, and then I'll send you a fixed thing. Oh, thank you. It's a good thing I don't have important papers later on right now. Okay, so I hope you have a good night. Send me questions, yes?
Yes.
Good night. Is it past your bedtime too?